Hello friends, today I will discuss about one of the career aided scheme, that is permissive underreach transfer trip, that is in short PUTT scheme for distance relay. So friends, before going through this video, you are requested to please go through my channel and do subscribe my channel and also press bell button for notification of videos to be uploaded in future. So in order to understand the permissive underreach transfer trip, let us take a very simple example, that is considering of force substation. So in between substation A and substation B there exists only one feeder, and in between substation B and substation C there exists another feeder, and substation A and substation D there exists another feeder. So zone 1, zone 2 and zone 3 reach of substation A end has been shown by green line. Zone 1 is the 80% of the protective line length. Here protective line length is the line section AB, and zone 2 is 120% of the line length for single circuit line. If it is a double circuit line, then it will be a line protective line length plus next 50% of the next shortest line. Again, zone 3 is in order to cover the next longest line. So zone 1, zone 2, zone 3 reach from substation A end has been shown by green line. Again, from substation B end, zone 1, zone 2 and zone 3 reach has been shown by blue line. So a fault occur, that is at a percentage of 90%. Let us consider the fault point at F, which is occur from zone 2 from substation A end, but it is occur in zone 1 location from substation B end. So as per normal distance scheme, relay at B end will trip zone 1 time, that is at instantaneously, and relay at A end, since it is located at zone 2 location, it will trip after some time delay, that is of 350 to 500 millisecond. So the fault point is underreaching of zone 1. Now again consider the fault occur at point F, which is located from substation B end, that is zone 2 location, and from substation A end it is located at zone 1 location. So the fault point is located the fault point is underreaching from substation B end in zone 1. So again due to zone 2 location from substation B end relay will trip after some time delay, that is of 350 to 500 millisecond. Again from substation A end it will trip instantaneously, that is at zone 1 time. So the tripping logic has been shown for both the substation relay end. Here the fault occur at point F at a distance from substation A end at zone 2 locations. Again from substation B end it is located at zone 1 location. So the tripping tripping logic has been shown for relay at substation B end, it will trip at zone 1 time, and timer T1, T2 and T3 are the timer for zone 2 and zone 3. Timer T2 is of the value of 350 to 500 millisecond, and value of the timer T3 is 800 to 1000 millisecond, that is 0.8 to 1 second. So since fault occur at from substation A end at zone 2 location, so after the T2 time it will trip the circuit breaker. So in order to avoid this time delay, PUTT scheme, that is permissive underreach transfer trip scheme, is employed in distance relay. The logic diagram for permissive underreach transfer trip, that is PUTT scheme for both the relay, has been shown in this figure. Here a simplex channel is required for permissive signal send and receive. So the scheme is very simple, that is if fault detected at zone 1, then it will send a permissive signal to the far end substation, and at far end substation the permissive signal will be received. If this fault is detected at zone 2 location, that is the zone 2 pickup is there and permissive signal is received, then it will trip instantaneously. So since fault occur at point F from substation B end, it is located at zone 1 location, so it will send a permissive signal. So Tx at B end will be high. Again, this signal will be sent by a simplex channel and it will be received at substation A end. That is, Rx will be high at substation A end. Since there is a zone 2 pickup and this permissive received signal is high, it will trip the circuit breaker instantaneously. So all the fault occur at zone 2 locations. Since there is a carrier receive or permissive receive, it will trip in zone 1 time. So tripping logic is zone 2 pickup plus permissive receive. This is the scheme for PUTT scheme. Again, let us consider fault occur at point F, which is located from substation A end at zone 1 location, and from substation B end it is located at zone 2 location. That is, it is underreaching of zone 1 from substation B end. Since fault occur at point F, which is located at zone 1 from substation A end, it will send a permissive signal from substation A end. So Tx will be high at substation A end. This signal will be sent via simplex channel and it will be received at substation B end. So Rx will be high. So since it is at substation B end, fault detected at zone 2 location and there is a permissive signal received, so it will trip instantaneously. So it will not wait for time delay, that is the T2. T2 is normally set at 350 to 500 millisecond. So this is the simple scheme for permissive underreach transfer trip, that is PUTT scheme for distance relay. So advantages of PUTT scheme: one simplex channel is required for permissive signal receive and send. This scheme is very secure and due to zone 1 initiation, in any end permissive signal will be sent to the other end. What are the disadvantages of PUTT scheme? If one of the terminal is open of the line, normal distance scheme logic will be applied for tripping. For examples, in between substation A and substation B, the breaker is open from substation B end and the line is charged from substation A end. So if fault occur from zone 2 location from this substation A end, this fault will not be detected from substation B end relay since the breaker is open. So normal distance logic will be applicable. Number 2, if there is no source in any one of the substation, basic distance scheme for tripping will be applied. For example, in between substation A and substation B, the only source is available at substation A end and there is no source at substation B end. So if fault occur from substation A end at zone 2 location, this fault will not be detected from substation B end. Since this fault, there will be no fault current will be supplied from substation B end due to unavailable of the source. So basic distance scheme will be applied in this case. Number 3, failure of signaling channel will result in basic distance scheme for tripping will be applied. So in order to successful operation of PUTT scheme, the carrier or signaling channel must be healthy conditions. Otherwise, PUTT scheme will not be applicable. Only basic distance scheme tripping logic will be applied. So these are the disadvantages of PUTT scheme.